Hello my dear students, welcome to the classroom, and as usual, let's build up the energy of the classroom. So I present to you Michael M. Silo. He was a famous rapper from Northeast India, and today let me introduce him to you. This is one of his top biggest hits. Just check out the rap. Deep down inside, I know a little bit of his rap because I used to sing at this rap when I was young. So good, so good. Ain't come to misery. Just a little kiss was the same kind of kiss that put you top on my list. There was you acting like I never knew about this now. Gotta close my eyes and drift away, put our past behind. I wish I could rap like this. So good, so good. And even the melody, check out the melody. The melody is so serene. It's very unfortunate that he is no more with us. He passed away some years ago, leaving behind a huge legacy and a big loss for the music industry. He was from Shillong, so we have lost a very, very precious and a very genuine hip-hop artist. This song is very old, but just check out the quality, the standard of his song. Just so lovely, so good. Such beautiful music, such good music. Alright class, that's it. So music is powerful. Okay, music is very powerful. It has the power to inspire someone. It has the power to uplift your spirit, and it has the power, okay, and you can use music to express your story. So that is why from time beginning, okay, people have been using music to express their feelings, their emotions, and then their happiness, their sorrow, everything. Music is a very powerful language, and interestingly, music has no language. Music has no language barrier. Okay, everybody understands music. So music is universal. So that is the power of music. Okay, so if any one of you, any one of my students who are watching this video wants to become a musician, I would say, okay, go ahead, because musicians, okay, I consider them as one of the most blessed people. Okay, I wish I was a singer. If there is one talent which I regret not having, is a good voice to sing. Okay, so that is definitely one talent which I regret not having. I have been blessed with so many gifts, but then to be having a good voice, and at the same time to be able to execute some like good moves. Okay, what will I not give to have that? Okay, so on this note, on this good note, on this energetic note, let's start a class. So welcome my dear students. My name is Benatang Paton, and together we learn in this classroom. Okay, so today's topic, my dear students, is here. Okay, extracting metals at the top of activity series. So these are the metals which are found in the activity series. These are the bottom, the metals which occur at the bottom of the series, known as low activity series, middle activity series, and high activity series. Our topic today, our discussion today will focus on this family, okay, the family of high activity series. So this is what we will study. These are the high activity series. High activity series. So my dear students, if you are new to the channel, then I always request my students to grab a book, a pen or a pencil, and then to write down notes, because this is gonna be helpful for you. Okay, so take down notes because it will help you. Okay, it will help you in your student life, definitely, because you will have to study notes. And if you're watching this video to gain some knowledge about the topic, then at the same time it will help you. So my sincere request is to take down some notes, okay, because that's gonna benefit you. Okay, so these are the metals which are very, very reactive, and being very reactive, How will they exist? They will exist always in combined state. So how do they exist? How do they exist? They exist in combined state. Okay, they will never occur in free state. Okay, free state metals, you will find gold, silver. Okay, they are the least reactive. Gold is the least reactive element, and so you will never find gold in combined state. Gold is always in free state. Okay, so they exist in combined state. So how do they exist? In combined state, how do we find them existing? In combined state, we will find them existing as in their metal chlorides and metal oxides. Okay, so in combined state, we will find them existing as their metal chloride, and metal oxides. All right. For example, metal chloride. If I say metal chloride, so if I say metal chloride, I can give you a very famous example, a very common example, which will be sodium. The metal is here, and Cl, NaCl. Nah? So this is sodium chloride. The metal is sodium. Here is sodium, second most reactive element, and chlorine. Okay. Then if it is metal oxide, then one example which I can give you is, I'll use calcium and oxygen. So calcium oxide. So this is what it is. What it means by metal chloride and metal oxide. So these metals, they exist in their metal chloride form or their calcium or their metal oxide form. Okay. So today we will be studying how to extract this. So to extract this, okay, to extract this metal. So say we want to extract sodium chloride. So we want to extract sodium chloride. Sodium, okay, so sodium, we want to extract sodium, not sodium chloride, sorry, we want to extract sodium. But sodium will be found as a compound, sodium chloride. Okay, now you know that sodium is has positive charge, is a positive ion, and chlorine is a negative ion. So the bonding between sodium and chlorine is very, very, very strong. Okay, I'm putting 3 V's. That means it's very, very, very strong. Do you know the name of the bonding which exists in this compound? The name of the bonding is ionic bonding, isn't it? What is ionic bonding? Ionic bonding is formed, okay, between two ions, okay, between two ions, okay, a positive ion and a negative ion. So the bonding is that of a positive and a negative. Okay, positive, negative. It's a very strong bond. Okay, and like I told you in my past videos also, that ionic bonding is one of the strongest bond. Okay, so it's a very strong bond. So now you tell me, will separating them be easy? Will separating them be easy? The answer is no. Separating them will not be easy. Okay, it's not easy separating them. So how do we separate them? Because we want to extract sodium. I want to extract this sodium. How will I extract sodium? It's not going to be easy. Okay, so whatever techniques that we have used for the elements at the low series, at the bottom series, and the middle series will not work for this. Okay, for the metals at the top of the activity series. I tell you again, will not work for this. Okay, it will not work for this. For this family, for this bottom metals, all we had to do was heat, plain heating, and the metal oxide gets converted to metal. That was how we did it. For this family, which is middle of the activity series, moderately reactive, what we did, we went for reduction with carbon. Okay, and then with that we got the metal of desire. Okay, we got it. We were discussing how to extract zinc, and we got the zinc. Okay, just by performing reduction. Okay, reduction with carbon, and we got the zinc. Now we are here, and remember, none of this technique will work here. Okay, none of this technique will work here. So then how are we going to reduce? How are we going to extract sodium? So for this family, for the metals which occur at the high of the activity series, for them a special technique, a special procedure is there. The name of the procedure, okay, is called electrolytic reduction. So that is what we are going to study. Electrolytic reduction. So my dear students, this is the technique, electrolytic reduction. Okay, it is, what is electrolytic reduction? Let me tell you what is electrolytic reduction. So you can write down electrolytic reduction. Electrolytic reduction is the use of current. Electrolytic reduction is the use of current to reduce the metal ions into their elemental form. So this is the definition of electrolytic reduction. Electrolytic reduction is the use of current. So we will use current, okay, to reduce the metal ions, which means this, okay, to reduce the metal ions into their elemental form. So basically what we will do, we will convert this Na plus, okay. So what we will be doing is, we will be converting this Na plus to Na. This is the ionic form of sodium. This is the ionic form. Okay, because it's carrying a charge, whereas this is the elemental form, and this is what we are after. This is this. Okay, so this is the elemental form. So we are after this. This is the elemental form. So we are after this. Okay, the same thing goes for, okay, chlorine. So chlorine has to lose this, but we are not going to discuss about chlorine because chlorine is not even here in the discussion. Our main primary focus is sodium. Okay, our target is sodium. How do we get this sodium, which is in its ionic form, bonded with chlorine? How do we extract this sodium, okay, which is in its metal chloride? How do we get this calcium, which is in its oxide form? So how to remove this? How to extract this sodium ion from its compound? That is our primary focus. That's what we are studying here. Okay, so sodium ion, okay, will be converted into its elemental form. Okay, so that's our primary focus, and to achieve that we have to perform electrolytic reduction. All right, so that's it. This is electrolytic reduction in definition. Okay, we'll study more. Okay, we'll go deeper, we'll study more about this now. Okay, so I just gave you the definition. I hope you write it, you have already written it. So to go in detailed discussion, it's not very difficult, my dear students. It is not very difficult, it's easy only. Okay, so just remember that you are dealing with metals of high activity. That's it. So their extraction procedure will be a little different. So the setup, let us understand the setup, and let us explain in detail, okay, understand in detail how actually the system works, how the whole procedure of electrolytic reduction works. So let me just write here electrolytic reduction. So to start, what we do is we will take a beaker, okay, a container. I hope the diagram is straight. Yes, like this. Okay, so this is a container. Let's just say a container, most likely glass. We will prefer it to be glass. Okay, we'll prefer it to be glass. And then what we need is we need molten NaCl. So what we need is we need molten NaCl. So we need molten NaCl. So let me write here. So NaCl, okay, this is sodium chloride. Okay, this is in its ionic form. So we have Na plus NCl, okay, minus, bonded together, and right now they are existing as a compound, okay, with a strong ionic bond existing between them. Okay, a strong ionic bond existing between them, making them this strong. It is not easy to remove this. Okay, very strong. Okay, so what we do is we will heat this ionic compound. Okay, so we will heat this. So we'll heat this. Now on heating, what will happen? On heating, what will happen? The temperature, this sodium chloride will absorb heat, and then the temperature will increase. And on increasing the temperature, what is happening? The bonds will become loose. And when the bonds become loose, they tend to move. There is more room for movement, for free movement, so they will start to move. Okay, that's what we will do. So we will heat this. So NaCl will be heated. Okay, heated tremendously. Okay, tremendously, or let's say high heat. Okay, instead of writing tremendously, I'll just write high heat. So highly. Okay, highly. So it will be heated very, very high. Okay, and then what will happen? On high heating, what will happen? It will convert to its molten state. Okay, molten state. What is molten? Okay, molten, the definition of molten is liquefied, okay, because of heat. So molten means when a substance behaves like a liquid because of heat. So we can write liquefied because of heat. So because of too much heating, okay, the object starts to behave like a liquid. This is called molten. So that's what we are going to do. We are going to heat this sodium chloride and convert it into this molten state. So let this be the molten NaCl. So now they have been heated. So now previously before heating it was like this, but now after heating the bonds become weaker and weaker. The bonds, okay, the particles start vibrating, and then the bonds become loose and loose, and thereby now they can move freely. So now they are behaving like a liquid because of absorption of heat. Okay, so now they can move freely. So sodium ion and chlorine ion, they can move freely. So sodium ion, chlorine ion, they can move freely. Previously before heating they were together. Okay, they were together, but now they can move freely. So in the solution you have sodium ion, chlorine ion, you have sodium ion, okay, chlorine ion, you have sodium ion, chlorine ion, okay, sodium ion, okay, chlorine ion, like this. Okay, you can just imagine like that throughout the solution. Okay, you have sodium ions and chlorine ions floating around because they are now in their molten state. I hope you are following. Okay, next what we do is we will take what? We'll take electrodes. So let me make a room for electrode here. So now we'll take 2 electrodes. So let's take 2 electrodes. So electrode number 1 and electrode number 2. So these are the electrodes. Okay, these are electrodes. So electrode, these are electrodes. These are inert electrodes. Inert electrode. Inert because what is the meaning of inert? Inert means, why am I writing because? Inert means inert. Inert means let me erase this one. Inert means it will not perform any reaction. What is the meaning of this statement? It means that these electrodes are not going to interfere the reaction. Okay, they have no role to play in anything which is going on. So these are inert. Okay, they are not going to play any role in the chemical reaction which is happening. Okay, that is the meaning of inert. And these electrodes are made of, they are either made of graphite or platinum. Now, so we have the electrodes. Now what will we do? We will bring a battery, a source for potential difference. So let the positive terminal be this side. So plus longer, minus shorter, plus minus, plus minus. Positive terminal, this is the positive terminal, this is the negative terminal. Okay, then it will go like this. Let it touch here. Then it will go like this. Let it touch the electrode here. So this is the positive electrode, this becomes the negative electrode. Now the confusion begins here, my dear students. This electrode on which the terminal is positive has a name. Okay, what is the name of this electrode? This electrode is called the anode. Very confusing. Okay, students always get confused with anode, and what will be the name of this electrode? It will be cathode. Okay, so this is cathode. Remember, this is cathode. Okay, here's the question for you. Then what is the name of this ion, and what is the name of this ion? Okay, do let me know in the name of the do let me know in the comment. Okay, what is the name of this, and what's the name of this? What is the name of this Na plus ion, and what's the name of this Cl minus ion? That will be the question. Okay, so please comment the answer in the comment box. What is the name of this number 1 and number 2? What do we call them? Okay, there's a name for this. Okay, which carries positive charge, there's a name for it. Which carries negative charge, there's a name for it. You let me know. So the positive electrode, the electrode on which the positive terminal is there, is called the anode, and the electrode with the negative terminal is called the cathode. Now what we do is we will let current pass through. So let's put a key here. Okay, a key here. Right now it's open, that means key has not been inserted. So let's insert a key. So when we insert a key, it will become like this. Okay, this is the key, this is called the key. Okay, now what happens? Now this is positive, okay, this is negative. So being positive, the negative chlorine, okay, the negative chlorine ion will be attracted to the positive anode. So chlorine ion Cl minus will get attracted to the positive anode. Okay, what happens? Now current is also flowing. Okay, so when this chlorine ion goes here, what happens? It will lose this negative electron. This negative, okay, minus means minus is brought about by electron. Remember, it is brought about by electron, because electrons carry negative charge. Remember this one. So chlorine ion loses electron, so the electron, okay, goes to this electrode, so loses this electron, and now this negative charge has become the electron, and this electron will travel. Okay, will travel. Where is it traveling? It will travel through the electrode to the wire. Okay, traveling to the wire to the cathode. Okay, it's traveling here to the cathode, and then this is positive, this is negative, this is a negative electrode, this is a negative electrode, and this is positive sodium ion. So positive sodium ion is attracted to the cathode, so sodium ion goes here. Okay, so the sodium ion goes here. Now remember that sodium ion is carrying a positive charge, one positive charge. Okay, then this electron is on this electrode, so positive charge, negative charge, okay, they cancel each other, and then this sodium loses its charge. And then when sodium loses its charge, what will become? It will become the elemental sodium. Remember, sodium ion, okay, sodium ion on losing charge becomes sodium metal, which is the elemental form. Okay, which is what we are after. So sodium gets deposited here, so sodium will get deposited here. Okay, then this sodium will also do the same thing. One by one, all the sodium will get deposited here, okay, on the cathode. All right, and one by one, all the chlorine which are floating around in the solution will all go here. Okay, they will lose the electron, and whatever the first electron did, they will all find their way here. Okay, so all the chlorine, okay, whichever got attracted to the anode, they will lose their electron, and all the electron will travel to the cathode. From the anode, the electrons will travel to the cathode, and once they go to the cathode, the sodiums, okay, the sodium, whichever, because all the sodiums will be attracted to the cathode, is not, because cathode is negative and sodiums carry positive charge, positive and negative, they attract each other, so all the sodiums will go here. okay, and then they will lose their positive charge, okay, they will lose their positive charge, and then they will become sodium metal. So sodium ion on losing its charge will convert to sodium metal. So what gets deposited here? This thing, okay, this blackish thing that I'm drawing here, these are all pure, these are all sodium metal. Okay, I will not say pure because it will only be pure after refining. This will definitely have some impurities. It will be 98% pure or 97% pure. So let's not say this is pure because refining is still there. Okay, the next topic will be about refining. So this is the metal, the sodium metal, okay, which we wanted to extract, and this is how we extract sodium metal, my dear students. Okay, this is how we extract sodium metal from its metal chloride. So sodium, it exists in this metal chloride as sodium chloride. Okay, so sodium chloride, what we do is we heat it. On heating, what happens? The tight bond between sodium and chlorine becomes loose. Okay, loose. So now they're in molten state, so it behaves like a liquid, and we pour the molten sodium chloride solution in this container where the sodium and chlorine ions, they are floating around freely. Okay, then we bring two electrodes. One is the anode, the other is the cathode. These electrodes are inert. Inert means they will not contribute to the reaction. Okay, they are not going to play any role in the reaction. Okay, so they are inert, made of graphite or platinum. When current passes through, what happens? These negative chlorine ions, they get attracted to the positive electrode, okay, and they lose their, okay, they lose the electron. So the electron travels through the anode all the way to the cathode, and the sodium, they get attracted to the cathode because the cathode is positive, negative, and the sodium ions are positive. So positive, negative, they attract each other. Sodium on making contact with the cathode, okay, because sodium ion will go and touch the cathode. Okay, it will go and touch the cathode. So on touching, will receive this negative electron, so its positive charge is gone, plus minus cancel, and it will convert to sodium metal. Okay, that's how we get sodium. This is how we get metals. Okay, this is how we get sodium, which is a very, very high reactive element. Okay, what about chlorine? Okay, what about this? So this chlorine, okay, chlorine is a gas, so two atoms of chlorine will combine together, and then it will exit out in the form of gas. So two atoms of chlorine will combine together because chlorine is a gas, okay, and it exists. This is the formula of chlorine, Cl2. Okay, two molecules of chlorine. Okay, chlorine is a molecule, so two atoms of chlorine will combine together, and this is chlorine gas. So chlorine being a gas, okay, it will exit out in the form of, okay, bubbles. So it will go out and escape out. Okay, so chlorine will escape out by becoming chlorine gas, but sodium metal will get deposited on the cathode. So this is what is happening. So to conclude the answer, we can always write one more thing. So what is happening at the anode? So reaction at anode. So what is happening at anode? At anode, which is this, at anode, what is happening? Cl minus, okay, chlorine loses the electron, so we have to write this. Okay, this is chlorine ion. Okay, so chlorine ion loses the electron and becomes chlorine. Okay, whereas reaction at cathode, what is happening at cathode? At cathode, what is happening? At cathode, sodium. So sodium ion, okay, receives electron, which is a negative charge, and it converts to elemental. This is metal sodium. This is sodium metal. This is the metal. This is the sodium metal, which is the elemental metal. So this is it. Okay, my dear students, this is extracting metals at the top of activity series. This is how we extract metals which occur at the top of the reactivity series. Okay, so I hope you understood. Okay, I tried my very best to explain to you. So I'll see you again, okay, in the next video. The next video will be about refining. Okay, that will be the last, and with this we will also be nearing the end of the chapter. After that, I have only corrosion to explain, if I'm not mistaken. So 1 or 2 videos along the way, and with that the whole chapter, metals and non-metals, will have been covered. So stay tuned and continue to study. Okay, so exams may be near, so study for your exam, and if these questions come in exam, I pray that you will be able to write and score full mark. So all the best for exam, and study regularly and study well.